Hello students, welcome to the channel Chemistry is Fun. In today's video we are going to learn how to calculate the formal charge. Okay, so what is formal charge? Formal charge is also said to be a fake charge. If at all you find any neutral particle, neutral molecule or a charged molecular ion. So in that, what kind of charge each and every atom is going to experience, or the charge that is shared among each and every atom in a molecule, is said to be the formal charge. Now what is the importance of this formal charge? Formal charge is used in order to find out which structure is having the less charges or it is more stable. Okay, accordingly we can know the stability of the molecule, we can know which product can be formed in the given reaction in a large amount. Okay, so formal charge is usually represented in a short form as Fc. Okay, the formula to calculate formal charge is group number or the valence electrons minus n. N indicates the number of bonded electrons minus half into B. So G indicates the group number, N indicates the number of non-bonded electrons. What are non-bonded electrons? As we've discussed in the earlier video, if you want, please go and check it out. Non-bonded electrons are nothing but the lone pair electrons which are not involved in the bonding, but still they exist in the valence shell. And what is B here? B is nothing but the bond pairs or the electrons that are involved in the bonding or the electrons that are shared among the two atoms. Bond pair electrons. Okay. So by substituting all these values, we are going to get the formal charge in a given molecule. Let us now actually apply this formula and check it out in a given example. So the first example could be CH3 plus, which is the methyl cation or carbocation. So in this, we want to know what charge is present on carbon as well as hydrogen. Okay, so formal charge can be calculated for each and every atom present in the molecule. Now first we'll calculate in carbon. The group number of carbon is how much? 4 minus number of non-bonded electrons in carbon are 0 because it belongs to 4th A group. And bond pair electrons are, there are 3 bonds around carbon which is bonded with hydrogen. So each bond indicates 2 electrons. So there are 3 bonds. So 3 into 2 you get 6 bond pair electrons over here. So which is equal to now 4 minus, this is half into 2 into 3 you get 6. Okay, so 4 minus 3 you get 1. So the charge on carbon is plus 1. You can see in the ion itself. Now similarly we can calculate the formal charge in hydrogen as well. Hydrogen belongs to which group? It is the first member of the periodic table. It belongs to 1A group. Minus number of lone pairs on hydrogen is 0. There is no chance of having lone pairs on hydrogen. Minus half into number of bonded electrons of each hydrogen is how much? Each hydrogen can bond with the carbon only by one electron. One electron will be contributed by one hydrogen, one electron will be contributed by the carbon. So altogether only one bond pair by one hydrogen. So the electrons are 2. So this will be 1 minus 1, 0. So the charge present on hydrogen is literally equal to 0. Whatever charge is present in the molecular ion, it is completely present on carbon itself. That is the way to calculate formal charge in a given example. Okay, let's take one more example, which is CH3 minus. This is carbanion. Okay, carbon compound with negative charges, carbanion. Alright, so let's calculate the formal charge in this molecule also for carbon. So what is the group number of carbon? Again 4 minus number of lone pair electrons are on the carbon. Now here, since there is negative charge, you have to take it as 2 electrons. So that means there is one lone pair on carbon, which is equal to 2 electrons, minus half into bond pair electrons are, it's the same, 3 hydrogens, so 6 electrons. So 4 minus 2 minus 3 is how much? Equal to minus 1. Okay, so this is minus 1. So the carbon is having minus 1 formal charge. Similarly, calculate for hydrogen also. 1 minus 0 into half into 2 is equal to 0. So in case of carbocation or carbanion, the formal charge on carbon is varying, but hydrogen remains the same. Now let's look at one typical example of nitrogen compound, which is NO3 minus, which is the nitrate anion. So nitrate anion has resonance structures. That means the shifting of pi electrons takes place in the molecule. Accordingly, the charge keeps on shifting from one atom to the other. So when you look at this structure, this is NO3 minus. There's positive charge on nitrogen, negative charge on both the oxygens. So positive and negative charge gets cancelled and the overall negative charge is only minus 1 in the molecule. Okay, now we need to write the Lewis dot structure for this molecule first. So what is the Lewis dot structure? By representing all the lone pair of electrons. Oxygen, since it is bonded to only one double bond, it will have two lone pairs on it. Now here this oxygen has got only one bond around it. It will have three lone pairs of electrons on it. Okay, now oxygen, the other third oxygen has only one bond around it. Again it will have three lone pairs on it. Nitrogen, its valency is usually common valency is 3. But here it has used up its lone pair also. So you can find a positive charge on this. That means nitrogen in this particular example has no lone pair. That's why we are not writing any dots on it. Now this structure, if you want to find out the formal charge, we need to first give the numbering for oxygens because there are 3 oxygens, 1, 2, 3. Now let's find out the formal charge in the case of nitrogen. So what's the group number for nitrogen? 5 is the group number, minus number of lone pairs of nitrogen in this molecule is 0, minus half into bond pairs are how many? 1, 2, 3, 4. 4 twos are 8. So this is 5 minus 4 equal to plus 1. Formal charge, you need to be very clear whether you are writing positive charge or negative charge in the in a particular atom. Okay, plus or minus signs are very important. Now let us look at the first oxygen. I'll write it as O1 to understand it clearly. Now oxygen belong to group 6. It has how many lone pair electrons? 2 pairs, which means 4 electrons. So 6 minus 4 minus half into oxygen has got how many bond pairs around it? There's only double bond attached to it. So 2 bonds equal to 4 electrons. So 6 minus 4, 2, and this is 2 2s are 4. So 6 minus 6 is 0. So as we have approached the answer, first oxygen has no charge on it. Its charge is 0. Now let's look at the second oxygen. Same group number is 6. Now the lone pair electrons are here 1, 2, 3 pairs, which means 6 electrons minus half into 1 bond 2 electrons. So altogether what you're getting here, 6 minus 6 is 0, 0 minus 1 is minus 1 charge. So that means third oxygen has got minus 1 charge on it. Similarly look at second oxygen has got minus 1 charge. Now look at the third oxygen. 6 is the group number minus 3 lone pair electrons. So it is 6 minus half into 2. So second oxygen is similar to third oxygen. So this also has minus 1 charge. Now the overall charge is represented in such a way that the positive and negative charges, they get cancelled and the ultimate charge is shown on the molecule. So plus 1 charge -1 charge gets cancelled, it gets neutralized, becomes 0, and this is the overall charge present in the molecule, where you can say it as NO3 minus. So according to the charge present in the given resonance structures, whichever has the least charges, that structure is considered to be the stable form. Okay, so this way you can take any resonance structure and find out the formal charge in a given molecule, and by using the above formula, and know the stability of the compound, as well as the yield or the product that is major in a given reaction can be known. Okay, hope this video is useful. Thank you.